Okay, perfect. Well, let's get started. Thanks everybody for attending a new Bytes of Innovation webinar. With Bytes of Innovation, we provide a deep dive into the future of medicine. And we do this together with renowned experts such as researchers, physicians, investors, and lawyers. And we do it every other Thursday. So we'll have one today, we'll do one in 2 weeks, and so on. The concept is 15 minutes of presentation by the expert, followed by 10 minutes of Q&A, which is moderated by Aline Lutz, who is the medical director at SecMed, and by me. So to all the participants, make sure to put your questions in the chat so that we can discuss them after the presentation during the Q&A phase. So today I'm proud to announce that we have Felipe Kitamura here. After finishing medical school and a master's degree, Felipe completed his residency in radiology and a PhD in deep learning in Sao Paulo, Brazil. And currently, Dr. Kitamura, he works as a radiologist and as a superintendent of applied innovation and AI at DASA. He is also the co-chair of the machine learning committee at SIM, and he's a member of multiple RSNA committees, including the machine learning steering committee. And on top of all of that, Felipe is a Kaggle competitions master. And today he's going to talk about data-centric AI in medical imaging. Felipe, the floor is yours.
Thank you so much for the kind introduction, Martin. It's a pleasure to be here. Thank you for inviting me to be here today with you all. Let me know if you can see my screen.
Yes, we can see it. Go ahead.
Okay. Thanks. So the topic I'm going to talk today is data-centric AI in medical imaging. These are my current disclosures. And I just want to state at first in the beginning that this idea of data-centric AI is being publicized by Professor Andrew Ng, who you may all already know. This is something that he has been working on and incentivizing people to work in the data-centric with the data-centric approach. So it's not my idea. I'm just trying to spread the word, as he said in his latest webinars. He's been asking people to spread the word about this idea, and this is what I'm doing here right now. So the main idea is that we know that any model, any AI model is made of the modeling part and the data part. And we know that the data part contributes to around 80% of all the effort, and the modeling part is responsible for around 20% of all the effort. And what people usually do is try to tune their own models, adjusting hyperparameters like these puns here show. And this is mostly what most of the researchers in the AI domain do in medical imaging or even in other domains. And although we know that most of the effort is done in the modeling part, like we're seeing here in these puns, we know also that the most important part that makes the final performance of the model be something similar to what we want to get is the data part. We know that the data is quite important, and this is why there's this saying that says garbage in, garbage out. So this is another pun from Dilbert showing that you can do whatever you want with data, it just have to make sense, right? So the main shift in paradigm here is to focus on data and not focus only in the modeling part. So as we can see here from Professor Ng's talk, 80% of the effort is in the data preparation and 20% is in the model part. And the interesting part is that if you look at, and Professor Ng made that, he made a research to see how many papers were focusing on the data part and how many papers were focusing on the model part. And 99% of the AI research is done in this 20% part of the model. So there's clearly something wrong here, right? Why are we focusing most of our efforts in the part that is responsible for 20% of the end result? So this is the main argument that Professor Engs brings, that the data-centric approach is the answer. Now, many of you may be thinking, like in this meme here, we all already know that. There's no news here. We know data is important. We know garbage in, garbage out. So what's the difference in the data-centric approach from what we already know in terms of the importance of data in training our own models? And the difference is the word systematically in this question. So we know we have to improve our data set before we train our models, but we often count on local individual skills to do this data pre-processing, data cleaning step. And the major idea behind data-centric AI is that how can we systematically improve our data and not only counting on local individual skills? So what I'm going to bring here now is some examples of those individual skills or some specific use cases where we see that the data preprocessing or the data annotation or anything related to the data part makes all the difference in the process of training our models. And the first one is related to this Kaggle challenge that was launched by Sim, Fisabio, and RSNA a few months ago. This was a chest X-ray challenge to detect opacities in the radiographs. So one thing that happened here in this challenge, and this also happened in all other machine learning challenges that used radiographs with bounding boxes as detection problems, is that the definition of the bounding box may vary according to the annotator. And these may be some subtle things, but most of them are very particular cases depending on how disease presents in each image. So this is an example here. Let's say we have these annotations in this X-ray, and we can see some opacities here. We can see that these bounding box fit the opacities. But another annotator could say, could potentially annotate this other way, which is considering these are two different opacities and drawing different bounding box here. Another annotator could consider the right bounding box to be this one, which is quite similar to the first, but it's just smaller and it fits better the opacities. And these are differences that we see every day when we work in machine learning problems, when we deal with people annotating data sets. And the thing here is, maybe there's no right answer. The only thing we need to guarantee is that we are able to standardize this annotation process and guarantee that most of them are going to appear quite similar. Otherwise, what's going to happen is that your metric is going to be not as good as it could be if the annotation was done in a more standardized fashion. So this is an example of bounding boxes and how this annotation process can be very important. Another way that annotation also makes a lot of difference is, let's say you want to build a brain triage classifier based on head CT. So you want to say if this is normal or abnormal. At first, it may seem to be a very simple task and a very simple task to be annotated. Let's say this one here is clearly abnormal. This second one here is clearly normal. This one here is clearly abnormal. But then you may find cases like this one here. So I'm not sure if all of you here are radiologists. If you're not, so this is something we call hyperostosis, which is just a bone proliferation in the skull. And in most of the cases, this is something that we consider a variant, something that is normal. It's not related to any kind of disease. In more rare cases, it may be related to some disease, but in most cases, it's not. So are you going to consider this normal or not? And if different annotators consider different things, your metric will suffer. Another thing, now it's not a variation. Here we have the maxillary sinus filled with liquid. Are you going to consider this an abnormality? Or are you focusing on brain pathologies only? And if you don't give that clear, crystal clear definition at first for the annotators, you're going to find different opinions, and the data set's going to be annotated in different ways. Another example, and now this is not medical imaging, this was another Kaggle challenge. This was a striking example for me on how the data preprocessing step may be of utmost importance. As you can see here, the scores for the second place on are all around 80%. And the first place got 96%, which is a huge gap. And people were wondering what happened here. And this difference here is explained by the data-centric approach, because the winning team, what they did was they came up with a way of, and this is the data that was being analyzed in this challenge. They came up with a way to clean the data and improve the signal to noise ratio. So what we can see here in the lower right part here, this is the signal of interest that we wanted to be detected. And you can see that it's very subtle in the original data, but after this pre-processing, they were able to make it much more evident. So just another example of how the data cleaning data part, and don't get me wrong here, I'm not saying we need to clean our CT scans or X-rays. I'm just saying there may be things we can do in the pre-processing step to make our models better. Another example was done here, and this idea was brought by Dr. Luciano Prevedello, a neuroradiologist in the Ohio State University. What he envisioned was, what if I'm trying to detect hemorrhage? What if I give colors to specific Hounsfield unit ranges? Specifically in this case, in the range we know there's hemorrhage. And he did that, and impressively, the model results got much better, even though we know that there are many other things that are not hemorrhage that fall within that same Hounsfield units range. So these are just some tricks to show that there are some things that we can do to improve our models that are related to the data preprocessing part and not exactly to the modeling part. So this is what I wanted to tell you today. My takeaways from this talk are that it's quite important to define crystal clear annotation criteria. There's no such thing as over communication, especially when you have multiple annotators. You have to make sure everyone understood what you said. And also, the labeling process must have some kind of quality control, especially for the test set. Otherwise, people may do different things, and if you don't check, if you assume they're doing the same thing, they may not be doing the same thing that you're assuming. Number 4, smart data preprocessing steps may be able to increase your model performance. We just have to make sure we're not adding any kind of biases here. And now, as we're talking about different preprocessing steps in the data, different ways of annotating, I think we are starting at a point that we are going to need more data versioning control systems, similar to what we have for code like Git, but for data as well. And the main takeaways from Professor Ng, this is not me saying anything here. This is Professor Ng's advice. He says we need high quality data in all stages of the ML project lifecycle, not only in the training part. MLOps tools can make data-centric approach more efficient and systematic, not only counting on the individual skills. And this is what he's been aiming at recently. And also that we should consider the data-centric approach in addition to the model-centric approach. This is not a substitution. This is an addition approach. If you want to know more about this, NeurIPS has this data-centric AI panel, and they have also this website, datacentricai.org, where you can see many resources, many papers, also with videos and PowerPoints and links to the original papers. That's what I had to say. I'm happy to take any comments or questions from the audience.
Thank you, Felipe. Thanks very much for sharing your knowledge. So we are opening for questions. Well, I do have one question to start. So my question is, let's say your algorithm is not performing well. How do you recognize if you need, for instance, to work more on the pre-processing of the data that you already have, or if you need to increase your training data?
Okay, yeah, I think that's a great question. And I always reference Professor Engs because I think he has this very nice framework of handling the entire training process. So one thing is to try to start small, train smaller models, and make sure you fit your training set first. And if you're not able to fit your training set, then you may have to increase your model size because your data may have more details than that smaller model is able to capture. But if that doesn't work, you probably have some sort of issue with your data. It may be with the pre-processing step. It may be with the annotation. It may be with the data set itself. But if that trick of increasing the model to make sure you fit the training data doesn't work, what we know is that there's something wrong before the model. So anything before the model may be the issue. It may be the data augmentation or any other thing. But if it works, if you're able to fit your training data with a bigger model, then you're going to focus now on the validation step, which is make sure your model generalizes, make sure it's not just overfitting your training set, but making sure it generalizes to the validation set. So yeah, I don't think there's a specific trick that is like one size fits all here, but I think maybe this is a more general advice.
Yeah, I agree. Sometimes it's a matter of trial and error. Okay, there are some questions from the audience. So Bernardo Pereira is asking, in cases where you have large amounts of machine data that you collect automatically, how would you control the labeling quality? And on the top of that, I'll add another question that is related. If there, in your project at DASA, if you have some adjudication system that you use.
So for Bernardo's question, I think the insight here may depend on exactly what specific kind of data you're working with. But if I understood your question, Bernardo, you're saying you have a specific use case that the machine generates the data. For example, maybe this is an example of what you're saying here. If you're trying to predict how long a patient is going to wait in the reception of a hospital, after the patient has gone to consultation or any other procedure, you already have that information because you have all these status changes of where the patient was at any time. So in this case, you already have the ground truth for everything. And that makes it possible for you to retrain your model in a more automatic way. But that's not the case for medical imaging usually, because we usually need a radiologist to see the image, to read the image, and tell you if there's a specific disease or not. So for the case that you mentioned, if I understood your question, I think the best approach could be to analyze prior data and try to find some cases that are off the grid, some cases that were not as you expect them to be. And by analyzing that, you may come up with some rule-based approach that could identify those cases. But this is not something that will work for all the use cases. You know, this is something that I think looking at your data is something very powerful, because it makes you come up with ideas that you may not have thought before.
Awesome. Felipe, thanks a lot for an awesome presentation. You were, I think, the first one so far who actually stayed within the 15 minutes. So that's big props for that. So I see there is another question. Are there different styles or practices for annotation that are consistent across medical schools or techniques? And if we can learn these different styles with AI?
Yeah, so I'm also not sure if I got exactly what Philip meant, but we see there are, I mean, when you are trying to put together a machine learning project and you have multiple annotators, I think the only thing you know for sure is that they will definitely do different things and different from what maybe the instruction, even if the instruction is the same for all of them, it's quite difficult to have very specific instructions that are not ambiguous, you know. And these makes, you know, medicine is not an exact science, so people have different interpretation on what you say. So I'm not sure if this is what he meant as styles, but this is something that we see happening all the time in all the projects that have multiple annotators. Another thing that may be more related to these styles that Philip mentioned is that different medical schools have different classification criteria for different diseases. For example, the aortic aneurysm classification. There is the famous Stanford classification, but there are many other classifications. So we do see those kinds of different styles. They're not exactly styles, but different schools of thinking in terms of classifying diseases, classifying anatomical regions. For example, another example is the internal carotid segments. There's the French classification and the English classification.
Yeah, I guess education is probably the best way to kind of get these different styles into the same direction. But yeah, there are always different definitions of how do you segment certain anatomic body parts, of course, and it's really hard to make those confirm or like in the same style. That totally makes sense indeed. Okay, I see we have one last question in the chat box. Do you see active learning as a possible step to improve data-centric AI?
Yeah, and I think Eduardo made this awesome question. I'm pretty sure active learning is a good direction in data-centric AI. Even if you go to that website, the datacentricai.org, many of the papers there use active learning as a way to sort your data set in a more intelligent way. So you annotate the most important cases and you end up not needing to annotate the entire training set. You annotate just part of the data set, and that is responsible for the same performance in the end. So I do think there is a major line of research in this direction of active learning.
Awesome. Okay, well, we're at the top of the webinar now. So thank you very much again, Felipe, for an excellent presentation, super interesting. And I think for us at SecMed, this is also very relevant as we are, of course, completely focusing on data and improving the data quality. So for us, this is actually good news because this is what we are in the core focusing on. So thank you again. And we're excited that in 2 weeks, we'll have Robert Pearl, who is the former CEO of the Permanente Medical Group, and he will talk about breaking healthcare's technology rules. So thank you all for attending this, and I hope to see you in 2 weeks.
Thank you for inviting me.